have the function x squared plus 4. Nope. X squared minus 4. And I have 2x minus 8. And outside of the parentheses, it's squared. So this isn't actually any of the specific problems on the stations that we did, but it is similar, right? It's kind of like a mix between station 1 and 2, what I'm about to go over. Or technically it's station A and B. But I'm going to be talking about how to find end behaviors and whatnot. How I can figure out how to graph this function. So let me actually add some more details to my graph. Right, like when we see a graph, it has these X markings where this is this first one. Dang it. This is +1, right? And this would be -3. I'm gonna get rid of those just for it to be a little more clean. But pretend this is my f of x function, right? F of x equals my x squared minus 4 times 2x minus 8 to the power of 2. If I want to graph this, I know I need a few things. I need my, I don't want that color. Hold on. I need my end behavior. Is it a positive or a negative leading coefficient? Right, you remember our 4 different graph shapes with our chart? Those are important. I also have to know, is it a even versus odd degree? But that's not it. I also need to find my x-intercepts. Let me actually make that another different color. Get all the different colors in here, why not? I need my x-intercepts. How do I find x-intercepts? I'm going to set my factors equal to 0. My factors are what's inside of my parentheses, right? So my x squared, set factors equal to 0. That's like doing x squared minus 4 equal to 0, right? So if I go back over to my function, and I actually do set x squared minus 4 equal to 0, in order to find what x is, I gotta get x by itself, right? I do that, I add 4 on both sides. I get x squared equals 4. In order to get x squared down to just x, I have to take the square root. I get x equals positive or negative 2. That positive or negative sign I had mentioned, that's going to show up every time we take a square root. So if I instead had x squared equals -4, which you might see on the test, I'd still take the square root of both sides. I get x equals plus or minus some number. But because this is a square root of a negative number, I'm going to have my I on the outside, right? And then the square root of the 4 gets us 2. So I could write this as, oh my gosh, I could write this as I2, but most of the time we've seen this as our answer as plus or minus 2I, right? But again, that's just an example. That's not the case for this problem. But that will show up. Imaginary numbers are unfortunately here to stay. So I got my x-intercepts, right? I got x equals a -2, and I got x equals a +2. Sometimes on the test, you might be given what the x-intercept is. If you were given an x-intercept of 2, 0, that's telling you that the factor of the function that the graph is on, we know there has to be an x minus 2 in that function in order to have an x-intercept there. Because +2 is what makes this factor equal to 0. Again, not the case in this problem, but it might show up. I know I erased it, but you could pause the video, take a little note down. I just need to conserve space because there's a lot of stuff that I'm going to be writing. So x equals -2, x equals +2. I'm just going to put those intercepts on my graph at, oh my god, I keep hitting the button on my pen. There's one at -2, and there's one at +2. Right? What do you think the multiplicities of these two intercepts are? I could imagine someone saying, oh, they're going to be a multiplicity of 2, because it's x squared, right? But in this case, x squared minus 4, I did this square root already. So these are both multiplicities of 1. So when we do inevitably graph these, it's going to like pass right through that point. Remember, we talked about like a multiplicity of 1 passes right through, a multiplicity of 2 bounces off. But that might show up later in this problem. And then a multiplicity of 3 would like squiggle through the point. So I still got to find the x-intercepts here. I have 2x minus 8 equals 0. Let's swap colors again. I got to solve that for x, so I'm going to add 8 on both sides. I get 2x equals 8. Again, I need x by itself, so I have to divide by 2. I get x equals 4. So I have another x-intercept on my graph at x equals 4. But now I see that this parenthesis is squared. That tells me I have a multiplicity of 2 at my blue point on my graph. So I know it's gonna bounce off that point. But I can't graph yet until I know where my graph starts and where my graph ends. I need to know my end behavior. So I'm just gonna erase this so I have more room. Doesn't mean it's not important. If I'm looking for my end behavior, I need to know what my highest exponent is. Again, I could see why we might think our highest exponent would be a 2. Because we've always talked about how degree is our highest exponent. But that was when we were looking at a function in standard form, right? Like our ax squared plus bx plus c. But in this case, this f of x function is very much so in factored form. So I have to pay attention to all of my exponents. So like if I were to fully simplify this function, this is technically x squared minus 4 times 2x minus 8 times another 2x minus 8. That's what that multiplicity of 2 means, because we're multiplying the same thing twice. When I'm thinking of all of these being multiplied out and I'm looking for my highest exponent, I know that's going to be x squared times this 2x times this other 2x. There's no other like multiplication that's going to get me a higher exponent than that if I multiply my highest exponent of each factor together, if that makes sense. I hope it does. But if I were to put this into standard form, I'd have x squared times 2x. That would be 2x cubed. 2x cubed times another 2x. That would get us to 4x to the 4th. So I'd end up with some 4x to the 4th plus something x cubed plus something x squared. That all doesn't really matter because we just care about what our highest term is. So I'm looking at my leading coefficient. Is 4 a positive or negative number? It's positive, right? I don't see this negative sign out front. And then is my exponent, or my degree, even or odd? Last time I checked, 4 is an even number, so I have a positive and an even graph. If I remember my chart, a positive even graph, that's like that U shape, right? Man, it's a U shape. So I know when I start my graph over on the right, let's do it in green. it's going to have to go up on the left and up on the right. And then I have my 3 x-intercepts. So I'm going to start on the top left. I'm going to come down to my first x-intercept. Oh my gosh. It has a multiplicity of 1, so let me make this a little more straight. It's going to go right through the point. It's going to come back up to my second x-intercept at x equals positive 2. I see that's a multiplicity of 1, so it's going to go straight through. And then it comes back down to my third x-intercept. But that's a multiplicity of 2, so I bounce off and go up to the right. As you can see, my graph is not that pretty. On the test, I will not be grading you on how well you can draw. This is math class, not art class, right? So, as long as I can tell that there's a clear distinction of the end behaviors, that it's going up to the left, up to the right, and that it goes through a point that has a multiplicity of 1 but bounces off a point that has a multiplicity of 2, that's all I care about. So, yeah, I mean, I think that's it for this problem. If this didn't make that much sense, I am going to post a couple other videos, maybe only one other video. We shall see. Going over kind of a similar process, not specifically graphing, but working on like finding x-intercepts, finding zeros, doing some factoring. But yeah, good luck.